Hi everyone, today we are working on 2.2 objective patterns and inductive reasoning. For the patterns we will use logic. For the inductive reasoning, which is the process of arriving at a general conclusion based on observing patterns or observing specific examples. Now conjecture is a powerful method of drawing conclusions, but we can never be absolutely certain that these conclusions are true. For this reason, the conclusions are called conjectures, or educated guesses, Now, I'm going to repeat this one more time. For the pattern, it's easy. You use a common sense logic. Inductive reasoning is the process of arriving at a general conclusion. But since this process is not absolutely certain, the conclusion we get, it's not absolutely certain is correct, then we name these conclusions conjectures or educated guesses. Okay, so look for the pattern in each list. So this is pattern, we're going to use logic here, okay? So look at the part A. They said 3, 4, 6, 9, 13, 18. And if you check, they are all increasing. But they are increasing slowly. Okay, so when they increase slowly, I always start with adding. Like, let's add 1. 3 plus 1 is giving me 4. Okay, true so far. We're going to keep going unless either we're going to get the answer or either we stop somewhere in the middle that we get the wrong answer. Then I have a 4 plus probably 2 is giving me 6, right? Then I have, let's see, then I have 6 plus 3 is gonna give me 9. I'm just gonna go slow so I count, add them in my head and see if we're getting right. So I have 1, 2, 3. Then I have 9 plus 4, 9, 10, 11, 12, 13. Okay, that's correct. Then 13 plus 5 is giving me 5, 6, 7, 8, 18. Okay, we're good. You see? It's going in order, like adding 1, 2, 3, 4, 5. So the next one is going to be 6, 18 plus 6, which is going to give me 24. So my answer for this is 24, the next number. Let's do B. B is increasing. We can see it's increasing, but it's increasing rapidly. When it increases rapidly, then the first thing you should try is multiplication, because multiplication is making it so fast increase. 3 times 2 is giving me 6. Okay, we are good there. 6 times not 2, but 6 times 3 is giving me 18. So let's try 6 times 3 is 18. Which see if we can get some pattern. 18 times 2 is going to give me 36. And I have to do all of them to see if I'm right, okay? Then 36 times, we're supposed to get 3. 36 times 3 is giving me 108. Okay, we are good so far. Then 108 times 2 is giving me 260. Did you guys see this? 2, 3, 2, 3, 2. The next one is going to be 3. So that's the one we need. 216 times 3 is going to give me, what is this going to give me? 648. So my answer for the next one is 648. So this is something like we use logic that it's increasing slow. Then I said, okay, let's start adding. It's increasing rapidly. So I said, okay, let's multiply. Okay, let's try this one. Look for the pattern in each list, then use this pattern to predict the next number. Let's do A, part A. Look at the A. 1, pick the third number, 2. You see, if I add 1 plus 1, I'm getting 2. I mean, this is something like I'm doing educated guesses. 2. Then what do? If I do 2 plus 1, it's going to give me 3, which is also making sense. right? So 2 plus 1 is going to give me 3. What else I'm doing? Okay, if you guys pay attention here, that's what's going on. The first two numbers are 1. Do you see that? Each number thereafter is the sum of the two preceding numbers. Like these are two first the same number. So if I add 1 plus 1, I get 2. If I do 2 plus 1, like 1 plus 1 is giving me 2. 1 plus 2 is going to give me 3. 3 plus 2 is going to give me 5. This is how it's going. 3 plus 2 is giving me 5. You see? Then 3 plus 5. 3 plus 5 is supposed to give me 8. You see that? That's how it's going. So if like the preceding number is adding, so we're going to use this pattern. So 21 plus 13. Okay, let me try this. 8 plus 5 is going to give me 13. 13 plus 8 is going to give me 21. Then 21 plus 13 is going to give me 3, and 1 is 4, and the other one is 3. So 34. So this is 34. Part B. Look at the numbers. Okay, let's make sense out of it. These are really huge numbers, like they are big numbers. So look at this. If I add 2 and 3, I'm getting 5. Right? 2 plus 3 will give me 5. But add 1 with the last number, 3 plus 1, it's going to give me 4. So I'm going to try this. 2 plus 3 is going to give me 5. And this 3, I add 1 there, and it's going to give me 4. So I got 54. See if it works for the rest of them. If it doesn't work, then in the middle it's going to be messing up somewhere. Then let's try this. 5 and 4. 5 plus 4 is giving me 9. If I add 1 there, it's going to give me 595. Okay, we're good so far. Let's try 95. So I'm adding 9 and 5. So 9 and 5, 9, 10, 11, 12, 13, 14. It's giving me 14. And I'm adding 1 number here. It's going to give me 6. Do you guys see that? Okay, so we're good here too. Let's add, since I have 3 digits now, so I have to add all 3. 6 plus 4 is 6 plus 4 plus 1. So that's giving me 11. And since the last number, okay, I should have done this in order so you guys would see it. Okay, let me try again. 1 plus 4 plus 6. So it's going to give me 11. And that last number, add 1, which will give me 7. So 117, cool. Now let's do 98. 9 plus 8 is going to give me, what? 9 plus 8. 9 plus 8 is 17, right? And this last number, you add 1 there, it's going to give me 9. So the next number is 179. So you guys have to be really observing all these patterns to get the answer. Okay, let's do this. Notice 2 patterns in this sequence. And this is inductive reasoning that these are all patterns that we used logic. Now we have inductive reasoning, like we are observing the patterns. That's what the definitions say. Arriving at general conclusion based on observing patterns or observing specific examples. So I'm observing different patterns and examples, which means I'm drawing a conjecture, educated guesses. Okay, so look at this. They said to draw the next figure in the sequence. You can tell it's a circle, square, circle, square. The next one is circle. But if we draw those patterns inside the circles, I know I'm getting to this circle. So it's going to be 3 dots here, 2 dots here, and 1 right there, like this one. Okay, this one repeats. Then I'm going to have another square, which is going to be this, and so on. Okay, let's try this one. Study the list of the circle. Use the pattern to answer the question. Now, in this, this is part A of it. Then again, they said make a conjecture about the color of the 11th circle. Color, okay? Color of 11th circle. What is the color of 11th circle? I don't know. Let's see. This is number 1. That's 2. That one is 3, and that one is 4. If you notice, odd numbers are red and even numbers are blue. And since 11 is odd, then it's going to be red. You can see this. You see, odd numbered circles are red. Even numbered circles are blue, right? So 11 is odd number, so 11 is an odd number. So we conjecture, we conjecture that the 11th circle, is red. Okay, that's how we figure it out. Part B, make a conjecture about the number of the regions in the 11th circle. Since 11 is odd, right? We already found the color of it. It's supposed to be red. Then look at this, the regions. Now, what about the regions here? I have 2 here. I have 4. This is 6, and that's 8. Now, if you check, each one of the circle is increasing by 2 every time. So if I have 11th circle, you multiply this by 2, it's going to give me 22. So 11th circle has 22 regions. You see it? 2, 2, 2, 2 every time. So has twice as many regions as its number in the list, right? So that's twice of 2. Question number C, make a conjecture about the appearance of the 11th circle. So we already know the 11th circle has 22 regions. 22 regions formed by the diameters. Formed by diameter. Okay, so we already figured it out. 11th up here. 11th, 22 regions. Okay. Part D is make a conjecture about the appearance of 30th circle. Okay. Now 30th circle, since we already know, let's figure out what the color is the 30th circle, because they said appearance, so we have to give them color in regions. So the color for the 30th is even number. So, and we already know even number is blue. Like this is 1, 2, 3, 4. So 11 even or blue. So we can say 30th circle. 30th circle is blue in color. Color. What else? What else we know? Regions. How many regions we have? Since every region we already know twice, it's increasing. So it means 30 times 2 is going to give me 60. So we have 60 regions for this 30th circle, and it's blue in color. Okay. Let's figure it out. What are they talking about? The counterexample. What is counterexample? Now, counterexample is an example. I'm going to write the definition here. Counterexample is an example that shows that a conjecture is false or incorrect. Counterexample like opposite, what we say. Okay, so let's do part A of this. Find a counterexample to show that each conjecture is false. Now, let me try this first. They said that product of two numbers, for example, 3 times 4 is giving me 12. is always greater than either number. Like this 12 is greater than 3, which is true. This 12 is also greater than 4, which is true. So either number, this is 12 is greater. Is that true? That this is conjecture, that was educated guess. So how do we give them counter example for this? If I take the same example and I negative 3 times 4, it's going to give me negative 12. Is negative 12 greater than negative 3? No. Is negative 12 greater than 4? No. That's my counter example. You see that? Which means the conjecture is false because it is not always true. So I can say conjecture is false because it is not always, not always true. Okay, let's do part B of it. Find a counterexample to show that each conjecture is false. All apples are red. I think simply find one apple that is not red. For example, Granny Smith apples are green. So that's not all the apple. The conjecture is false. It's incorrect. The counterexamples, you can give them like a Granny Smith apples or green. Okay, so that is false when they said that all apples are red. If you guys have any questions, please comment below. I will try my best to answer it. And if you have if you're new to the channel, make sure you subscribe and like the video if you learned something there. Thank you. Bye.